Hello, I'm Jordan Baumgartner, and this is an Oklahoma World blog video on how to read Skew-T log P diagrams. What a Skew-T log P diagram is it's a graph. Now, you can see on the left, there's a lot of lines in here. It may look confusing at first, but once we get into it, you will see that they aren't that difficult. You just have to pay attention to what you're doing. So, how does it get its name? Well, on the left, on the vertical axis, you have parcels in hectopascals, which is just an SI unit or scientific unit. And with each, it decreases normally in increments of 50 or 100, depending on which graph you have. And then that's the log P part. And then the Skew-T part is the temperatures, which is on the bottom axis. And instead of them just going vertically like you're used to, they actually go up to the right at about a 45-degree angle. And so you have those temperatures which are skewed, so it's Skew-T. And then what a Skew-T essentially is a level balloon that goes up, and it's the result of that. And it gives meteorologists a look into the atmosphere at a specific point at a specific time. And like I said, meteorologists can use this for all sorts of things. And then, in addition to showing temperature and pressure, they can also show wind speed and direction, which is shown on the far right of this diagram. This is calculated via GPS. Okay, that's a quick overview. Let's take a look at what all of these lines are. So as we bring this up, first, I already mentioned pressure to the right. It's in hectopascals. Again, it's a scientific unit. And then temperature, there's that. That's in degrees Celsius, which is an SI unit. And then one more line on this one is a mixing ratio, grams per kilogram. Mixing ratio is the amount of water per the mass of water and a mass of air. So you get, and normally this is only a few grams per kilogram, so there's not a lot of water in air. Okay, so let's move on to some other lines. There's two specific lines called adiabat. One is a moist adiabat and the other is a dry adiabat. What a moist adiabat is how much the temperature decreases if the parcel is moist. Now this line will change based on the amount of moisture in the air and the temperature of the air, and the volume of the air. So that controls how fast the temperature decreases with height. And this is when energy is conserved inside the parcel, so it's not giving or losing energy inside the parcel. Okay, so the moist adiabat, and then we have the dry adiabat. The dry adiabat is constant at 9.8 Kelvin per kilometer or 9.8 degrees C per kilometer. Again, scientific units, it just makes things easier for our calculations as meteorologists. So you can see there's kind of a slope on that line. And now then, let's go back and see, you may notice these two big bold lines here. And these have two different things. The one on the right, that's going to be temperature, as you can see. And then the other one is dew point temperature, or this is the temperature the air will have to be at for there to be 100% relative humidity. Okay, so that's pretty much all the lines you need to know on a typical Skew-T to be able to plot them. So let's practice plotting some points here. First, let's do a negative 10 degrees Celsius at 1,000 hectopascals. So what we do is we find our 1,000 hectopascals line and draw a line across there. An imaginary line, you don't actually put it on your paper, but so you drag it across, there you go. And now negative 10 degrees C, what we do is we come down to the negative 10 degrees Celsius and follow that line up and to the right. And where these two lines meet, we put our point. And that's negative 10 degrees Celsius at 1,000 hectopascals. And now we'll do the dew point. Dew point sometimes is given you either have a dew point temperature or you have a mixing ratio temperature which you can plot. In this example, I'll only do a dew point. You can find resources online. I'll post a link in the description that can help you find it if you're given mixing ratio. But let's just do a dew point temperature. So negative 15, we're going halfway between the negative 10 and negative 20. Draw a line up and to the right, and put a point where the line's intersect. Okay, that's pretty simple. The mixing ratio is a little bit trickier and requires some more advanced knowledge than we have covered in this video. We'll get to this in future videos. So that does it for this video. So in upcoming videos, we will show how to find several meteorological parameters and what they actually mean, such as energy in the atmosphere, cloud base, and what have you. And then how meteorologists use these diagrams in practice. We'll go over a few examples that make meteorologists' lives a lot easier, and then we'll find some real-world examples to use these in. Okay, that does it for this video. Don't forget to connect with us on Facebook, Twitter, YouTube, and our website. Thank you for watching.